So it says use algebra. So that means we are not. So use algebra means we can't just put one side of the equation into our graphing calculator and find the x-intercepts or something like that. We actually have to solve this using algebra. And to start off with, we notice in this equation that it has a cos x and a sine squared. It has two different functions. Now, in order to solve an equation with two different functions, you have to separate those functions. Hello? Again, where were we at? We noticed that this function has a cos x and a sine squared x. So one of the strategies so far is to solve this, we need only one trig function to appear in here. And in order to do that, we have to use things like substitution or elimination like you've used in the past when you had an equation with two variables and you had to solve. So you need two equations in order to solve that. Well, you have another equation because one of our big ideas is that sine squared plus cos squared of x is equal to 1, and that's one of our identities. So now in this equation, I notice I have a sine squared. So if I can get sine squared by itself by subtracting cos squared on both sides from this big idea, I can now use substitution. 3 minus 3 cos x minus 2, and instead of sine squared, I can write 1 minus cos squared instead. What that does is it changes my equation. So now if we take this equation and distribute things out, we're going to get 3 minus 3 cos x minus 2, because this gets multiplied here, and the minus 2 also gets multiplied there, plus 2 cos squared x equals 0. And I recognize that I have a quadratic equation. How do I solve quadratic equations? Either by factoring or the quadratic formula. Either way, I like to write it with my cos squared first. I see that 3 minus 2 is 1. And so I can set this up, a plus 1. Set this up so that if I could factor it, then it's in a form that's nice to factor. Now, as far as factoring this one goes, so if I was trying to factor this, not knowing whether or not it were possible, the only way that I could get 2 cos squared is if I had 2 cos and cos to start with. And the only way to get a last term of 1 is if I had a 1 and a 1, either both positive or both negative. So now, when checking, does this actually work, I need this outside and this inside to equal 3. In fact, a negative 3. So I have 2 on the outside, 1 on the inside. Can you see that they would both need to be negative in order to get that negative 3 cos x? Again, once I factor, I always do a quick check. Do my first ones give me 2 cos squared? Do my last ones give me a plus 1? Yes, negative 1 times negative 1 give me plus 1. And does the outside and inside give me negative 3? It does. So at this point, I know that this has been factored correctly. Now we can split it up. Here, cos x is equal to 1/2. Here, cos x is equal to 1. Is a half on our pie plate? What values for cos? What family? Pi over 3. What quadrants? Quadrant 1 and quadrant 4. Is your x-coordinate ever 1? Yes. At what angle? 0 and 2 pi. So what I have done is I've solved it between 0 and 2 pi. And I had scrolled down far enough that I can't even see the equation that I read at the beginning. And most likely, even though you read it at the beginning, you will not remember the domain that they asked you to solve. So one thing, after solving from 0 to 2 pi, go back and check, did I solve it over the right domain? No. what is the domain that they asked for? From 0 to 3 pi over 2. If you think about that, that's quadrant 1, quadrant 2, and quadrant 3. So when I go back to my answers, what do I have to do? I have to take out, it's not this one, because that's too far. It's not this one. This one's in quadrant 4. My only answers are 0 and pi over 3. And now I'm even a little bit nervous with 0, because was 0 included? Yes. See how there's an equal sign with the 0? But 3 pi over 2 wasn't included. So we have to also be careful with our inequality signs when checking what are our final answers. Okay, question for practice is number 10. For the last 15 minutes, I don't want you working on your reviews. We'll work on our reviews this afternoon. But I do want you working on your proofs. So take out your proof sheet